So here we have the temperature sensor built on the breadboard. For the functional blocks, we have the window comparator here, and then this lead is for the voltage input. We have the test switch so we can verify the circuit operation. We have the ADC here, and that's taking its voltage input from over here at the ends of these two diodes. And then we have our LED bar graph readout, so we know the state of this guy. And I had to use a 1K resistor for one of them because I lost one of these 1.3K resistors. And this is all being powered by the 80K here, right? So we use the V plus lead to put out 5 volts. And then this is our ground. And then we're using wave generator 2 because I'm still using wave generator 1 as our temperature dependent voltage. So this is just set to, as we can see over here, it's just set to DC. So it's just a steady DC voltage. And we're using it to simulate that temperature dependent voltage. So that just gets fed into the window comparator here. And that's how we simulate, changes in temperature, which correspond to changes in voltage, right? So right now, we're in our normal state where, within the negative 20 degrees to 10 degrees Celsius, which would correspond to that, voltage range that, that 0.75 to 2 volts. Where's my waveforms here? Okay, so we're within that, 0.75 to 2 volts. We're at 1 volt, right? So we're normal. We have 0 volts at the output or the input of our ADC. We have all these LEDs on, so we know everything's good. Awesome. So let's try going outside. Let's go below the lower threshold. So we'll go to 0.5 volts, which is below that lower 0.75 volt threshold. So if we take a look now, that state has changed. So we know something's wrong because in our normal operation, all these should be on and we know the temperature is good. So something's going to change, right? We can look as well at the voltage there. So we have 3.14 volts, right? Awesome. So let's go back into our threshold just so we can make sure that it kicks back to its normal state, and it did, right? So these are all on, temperature's good, great. So let's go above the upper threshold, right? So we'll do 2.25 volts, should be fine, right? So if we come take a look back over here, yep, this has changed. So now we know, hey, the temperature's not right. Let's fix it. So then also let's look at this voltage over here. Oh, okay. Sorry. And we have 3.140. So that's good, right? And once again, one more time, we'll do one more within the boundaries voltage. So 1.75. And then we can see these have all came back on. Hey, awesome. We're within our, temperature range. That's great. And we have 0 volts, 6 millivolts, essentially 0. The one other thing we need to test is this test switch right here. So I'm going to hit that. And as we can see, yep, the state changes, right? So that just tells us that the ADC is functioning properly. If I hold that just so we can take a look, I'm gonna hold it down and from the meter I get 4.133 volts. A couple things I had to do, which I'll talk about in the discussion, is I had to add like a current limiting resistor here. So I just used a 1K. Because if I hit, it worked in the simulation, but if I just hook this switch up to 5 volts and hit it, the 80K actually shuts off like due to current consumption issues. So I just used this to limit the current. One other thing I did, which I don't know if it would be necessary, but it actually seemed to help. So I'm gonna add it into the schematic. Is I added this 10K resistor here, basically just to help at the output when this is 0. This 10K just goes to ground, so it just kind of helps pull the input down to ground when there's nothing present, no higher voltage present. And yeah, that's pretty much it. So I'll talk about those things in the discussion. Thanks.